So the topic is very simple, South Atlantic Anomaly, and I'm your host, Sreejith. So moving further, what are we going to discuss today? This is an overview. As you would know, we are going to discuss South Atlantic Anomaly and introduction to this topic. What is Earth's magnetic field? Then the next topic would be Van Allen radiation belt. Don't get tensed or intimidated by the names. These are very simple topics. You would come to know about it in a bit. I will be taking them in as much detail as possible. But yes, let me tell you something that there are a lot of understanding you should have prior to getting to this. So I hope you know all such things. I'll just touch base on them. So if you don't know, you can go back and know those topics and then know those concepts and then come back to this. Okay. If it is required, I would be covering most of them and I would be touch basing on those that are not mentioned here. So that would be sufficient for you. So the next thing that we're going to discuss is like the process of what really happens in this South Atlantic Anomaly, and what is the impact of South Atlantic Anomaly and what is the way forward. So all these things we will be discussing today. Before going into this, so what do we provide at Genius Channel? We provide live interactive classes. We do have a website and mobile app for interactions. We have free courses, editorial classes, PDFs, MCQs, paid courses, civil service exams, CDS, NDA, Kerala administrative exams, TNPSC, banks, SSC, CLAT, all these things. And we also do provide optionals of history, Malayalam, public administration, and geography. Okay. So getting right into the topics, what is South Atlantic Anomaly? So it's, in short, you can call it as SAA. So throughout this process, you would see somewhere I have mentioned it as SAA, or somewhere I would have mentioned it as South Atlantic Anomaly. Both mean the same. So South Atlantic Anomaly is a behavior of Earth's geomagnetic field. So let's understand that the Earth has a geomagnetic field. Geo is the word because this magnetic field is for the Earth. So that is why I have used the term geo. Otherwise, you can just call it Earth's magnetic field. Both are one and the same. And that geomagnetic field, there is a slight change in behavior. Okay, so that behavior is observed in an area between South America and Southwest Africa. Between South America and Southwest Africa. You want to see what that looks like? Take a look at the image. And in the image, you can see there is a blue colored region stretching from South America to the southwest of Africa. So that region is where you see an anomaly in the behavior of geomagnetic field. See, don't go by the name. See, people can also be tricked by saying like this, if you don't know, if you're completely unaware of this particular name, so or of this concept, so you can be tricked by saying that this is some kind of anomaly in the climatic phenomenon. Okay, so that's not the case here. It's purely a geomagnetic anomaly. Okay, and even otherwise, anomaly is a term that's always used or that's mostly used with the behavioral changes in magnetic field of the Earth. Okay, so in that way also you can relate and understand it. So what actually does it mean? It signifies a weakening or a dent. I will come to those things. So this is just a definition purpose. So if you are writing a mains exam, you could use this in your mains writing. So be prepared for that. You can use this slide for that. So that's why I provided it as a definition. So it signifies a weakening of the Earth's magnetic field between Africa and South America. So there is a weakening of Earth's magnetic field. There is some behavioral changes and there is a weakening or a dent that is seen in the Earth's magnetic field between the areas that I mentioned before. In this area, what happens? What happens is like the Earth's inner Van Allen radiation belt. So from this particular thing, you can understand that there is something called a Van Allen radiation belt. What is it? We'll come to that in a bit. But there is an inner one of it. So basically there could be an outer one and an inner one. That is what we can understand from here. So there is an inner Van Allen belt which can come as close to the Earth's surface as at a height of 200 kilometers. So you can find Van Allen belt normally at a height of normally at a height starting at 640 kilometers from the surface of the Earth. From the surface of the Earth, you can find Van Allen belt at a height of 640 kilometers in a usual case. But in South Atlantic Anomaly, what you can see is you can find Van Allen radiation belt at a height of 200 kilometers from the surface of the Earth. So from 640 kilometers, it has dipped down to 200 kilometers from the surface of the Earth. So let's understand that particular point. Okay, so moving further, what is Earth's magnetic field? So basically, when you look at the definition and all those things, I said it's just an introduction. So you would not have understood anything from there because we basically talk about two important things there. One is Van Allen radiation belt, and the other one is Earth's magnetic field. So till the point that you don't have a clear understanding of these two terms, there is no point in understanding what is South Atlantic Anomaly. Okay, so let's understand what is Earth's magnetic field. So Earth's magnetic field is the magnetic field. See, a magnet. What does a magnet do? A magnet, you have studied in our physics class. You say like poles repel and unlike poles attract and all those things, right? So a magnet has two poles, a north pole and a south pole. So a magnet would have a magnetic field as well. If you remember, you would have drawn images of it in your physics lab in the school, and it would resemble something of like a butterfly, right? Different magnetic field lines starting from the north and ending at the south. Now starting from the north pole and ending at the south pole of the magnet. Okay, so on both sides of the magnet, you would have drawn that image. I hope that image is there in your mind from your school physics lab. Okay, and similar image is shown here, but here in case you're placing that magnet inside the Earth. So let's understand that there is a magnet inside the Earth. How does it come? How does it work? And all those things, we'll come to that in a bit. So you can see Earth's magnetic field, and you can see that there is a north pole. See, Earth has two set of poles. One is geographical poles and one is magnetic poles. The geographical pole is the north pole and the south pole, which is denoted by 90-degree north latitude and 90-degree south latitude. That coincides with the Arctic region and the Antarctic region respectively. Okay, so that's your geographical north pole. In addition to that, the Earth has a magnet inside it. Okay, we'll come to that in detail. But when you have a magnet inside it, so that magnet would have a north pole and a south pole. Where are those north pole and south pole placed? Now, for that to be understood, let's understand that unlike poles attract and like poles repel. So where should be the south pole of the magnet? The south pole of the magnet should be in the north pole of Earth, right? The south pole of the magnet should be in the north pole of the Earth, and the north pole of the magnet should be in the south pole of the Earth. So that is what you can exactly see in this image. The south pole S is in the north pole of the Earth, geographical north pole of the Earth, and the north pole of the magnet is in the south pole or the geographical south pole of the Earth. Okay, so that is what Earth's magnetic field looks like, and it shows a magnetic field. It starts from the north pole of the magnet, not of the Earth, of the magnet, and it ends at the south pole of the magnet. Okay, now how is this magnetic field generated? So for a magnetic field to be generated, if you remember again the physics lab, there was a magnet, a bar magnet that was placed on the paper, right? That is when you started drawing the magnetic field. So there should be a magnet here as well, which I already said that the Earth has a magnetic field. But how does an Earth has a magnetic field? Let me tell you something like that, something into that. See, the magnetic field is there for a magnet, but do you know that magnets as naturally occurring materials are very little in the inside the Earth. Okay, it's very little in volume, in amount, whatever you say, it's very little to be found inside the Earth. So you don't have natural magnets. See, materials that has magnetic capability in its natural form, it's known as natural magnets. As I said, there are very few materials or very little materials that has this property. If I remember it correctly, there was some name starting with D, I think dolotite or something like that. I had read many years back. That is an example of natural magnet. and it's found very little inside the earth, very little quantity, in very little quantities. Okay, let's keep that aside. So there can't be a permanent magnet, there can't be a natural magnet inside the earth. So what is the other thing? Induced magnet. Okay, what is it? Induced magnets. I'm just recapping the things that we have studied in our physics. There are induced magnets. Induced magnets can be of two types again, permanent and non-permanent. Right? Permanent are those ones which induced. What do you mean by? First of all, what do you mean by induced magnets? Induced magnets are the ones wherein magnetic field is induced by some process, right? And what is that process? If you remember, by passing electricity or current through a material. So that is how you can induce magnetic field into it, or induce magnetism into that particular material. Okay, so those are induced magnets. What are then permanent and non-permanent magnets? Permanent magnets are the ones which retain their magnetic field even after the electricity is removed, right? And non-permanent are the ones which loses magnetic field after some time. So this is how we understand it. And what are the materials? I said, like, you pass current through a material and it acquires magnetic field and all, right? So what is that material? That material is normally known as ferromagnetic material. Okay, so this is how it is. Now let's get into the interior of Earth to understand how magnetic field is developed for Earth. Okay, so you can see crust, then you can see mantle. Mantle has two layers, like upper and lower mantle. Then you go into the core. Core has two layers, inner core and outer core. Let's state the matters in there, or the phases of matter in here. So inner core is in solid state and outer core is in liquid state. But both of them contain more or less the same material, which is Nife, Nife, which is nickel and ferrum. So ferrum is nothing but iron. Now the issue is, the difference is in inner core, these same materials are in solid state, whereas in outer core, these are in liquid state. And do you know that in liquids and in gaseous materials, there is a phenomenon, or there is a concept that works, which is known as convection. What is it called? Convection. We would have studied it again in our physics, right? So convection happens inside this liquid material. So outer core being liquid, convectional currents pass through it. What do you mean by convection? Convection means basically the inner core is at a much higher degree temperature than the outer core. The inner core is at a much higher degree temperature than outer core. So the inner core heats the outer core from beneath. Okay. So when the outer core is heated from beneath, the lower layers of the outer core gets heated first. Those materials will come to the top, and on the other side, what happens is, like, the materials at the top of the outer core will sink down to the bottom layers, and this revolves like a cell, which is known as a convectional cell. You can see that in the right side image that I have provided here in blue dashed lines, okay, or lines showing lines with blue arrows. So this is basically a convectional cell looks like. Due to this convection, what happens is, like, an electricity or electric current is generated, which flows through this liquid core. That electricity, when it flows through the liquid core, the entire core, and let's remember one more thing, that this outer core, which is in liquid, it's also rotating on its axis, because the entire Earth is rotating. See, the entire Earth is rotating on its axis at a speed of 1 rotation per every 24 hours, right? So that's the speed of it. With that speed, the inner core is also rotating. In addition to that, the inner core has a convectional current flowing through it. The convectional current in turn produces a electric current through it. That electric current passes through this outer core, and the outer core is also rotating. So entire process that I mentioned right now gives rise to something known as a dynamo effect or a geodynamo effect. Normally it's called a dynamo effect in physics, but since we apply it to the Earth, we call it geodynamo effect. Okay, So that geodynamo effect, what it does is it creates a magnetic field. It creates a magnetic field for the Earth. So that magnetic field is called the Earth's magnetic field. I'll show you an image before explaining this particular slide. This is how it looks like. This is the magnetic field. You already saw it in the first slide of magnetic explaining magnetic field. Here is one another image showing the same thing. Okay, so can you see there is a north pole, there is a south pole inside the Earth, or a magnet inside the Earth having a north pole and a south pole, and then there are magnetic field lines emanating from the north pole ending in the south pole of the magnet. Okay, which coincides with the north pole of the magnet coincides with the geographical south pole, and the south pole of the magnet, sorry, the south pole of the magnet. I think there is a slight mistake in the image that I've shown it here. It's the south pole of the magnet which coincides with the geographical north pole, and the north pole of the magnet which coincides with the geographical south pole. Okay, there's a slight mistake in the image, but this is how it works. Okay, so and coming back, Earth's magnetic field. So what does it do, Earth's magnetic field? So the basic thing is the Earth's magnetic field is very important for Earth. When we delve deeper into this, that is when we understand that this is the reason why we have life on Earth itself. Because lack of magnetic field can lead to a barren land. Mars once had a magnetic field. Now it doesn't have. It has some few glitches here and there, or few in little bit here and there. That's it. But since it since the time it lost its magnetic field, the entire life on Mars is also lost. So how does magnetic field help in protecting the life on Earth? See, there are two kinds of harmful radiations that pass through our solar system. One is the solar wind. Okay, that is the wind that emanates from the sun, which contains very harmful charged particles. The second one is the cosmic rays. These are also charged particles, harmful radiation, but they do not emanate from the sun, but they are the ones which keep on passing through the universe. So they are passing through the universe, traversing from one galaxy to the another galaxy, traversing from one star and planet system to the another one. So that is how it is. So there are two harmful radiations. One is cosmic one, and one is the solar winds. All these things are so harmful that it can wipe out the life on Earth. First of all, it won't directly wipe it out, as it would take some years, but initial repercussions would be like it can alter the DNA of humans, of plants, of animals, everything. Okay, so such is the harmful effect of these radiations. Now, these radiations, as you see in the image, are actually deviated by the Earth's magnetic field, and the deviation is very much clearly visible in the image. Okay, so that's one case. Now, there is one more point that needs to be added here, which is about Van Allen radiation belt, but I'm not going to discuss that now. Let's keep that in mind. We'll check that out in a moment. And one more additional point that I mentioned here is the same Earth's magnetic field is responsible for certain phenomena known as northern lights, aurora borealis, and southern lights known as aurora australis. There is a spelling mistake here. It's aurora, not aurora. Okay, aurora australis. Okay, so keep that in mind. So you would have seen that a beautiful green colored, what do you say, orange colored or blue colored or purple colored sky and all. Right, those are these northern lights and southern lights. Okay, so that see, that's not the point of discussion for today, so I'm keeping it very short. I hope those things are already known to you. Okay, or else you would have to check our geography videos to understand such things. Okay, so this we already discussed, and this is how the magnetic field looks like. It's not very I mean, as you saw in this prior image, it's not as clean as it looks. It's really very complex. So this is one complex image showing the Earth's magnetic field. Moving further, Van Allen radiation belt. See, Van Allen radiation belt was discovered by a person known as James Van Allen. So that's why this name, Van Allen radiation belt. What is Van Allen radiation belt? It's actually a zone of energized charged particles. Most of them originate from solar wind. So as I said, the solar wind carries these charged particles and it traverses through the, or it travels through the solar system. When it tries to enter the Earth's magnetic field, the magnetic field of Earth deviates it. But what happens, what really happens there is, some of them is deviated, but before deviation, what happens is like this, the Earth's magnetic field would capture them. Not just capture them, they would be trapped. I'm using the word trap. They would be trapped in a belt kind of structure, which contains this charged particles. These charged particles are nothing but energetic electrons and protons. So such belt is created in which these charged particles are trapped. And that belt is created due to the Earth's magnetic field, because that field is the one which deviates them or captures them or traps them. Okay, and such a radiation belt is known as Van Allen radiation belt. Okay, so normally or permanently there are two such belts. One, as we mentioned in the starting, inner radiation belt, and one is the outer radiation belt. Okay, and some of them can be temporarily created as well. Now, where do these charged particles come from, which are trapped in this radiation belt? They come from two sources. One is the cosmic rays, and the other one is the solar winds. So, but it is mostly from the solar winds. Okay, I'm sorry. So, where is it found? The Van Allen radiation belt. It's usually found at the height of 640 kilometers to 58,000 kilometers from the surface of the Earth. So where do you find it? It's found, or the inner one is found starting from 640 kilometers. Okay. And the second one is found at a height of 58,000 kilometers. Both are calculated from the surface of the Earth. Okay. So this is the Van Allen radiation belt. So this belt is created by the charged particles which are trapped by the Earth's magnetic field, which were trying to enter into Earth or enter through the atmosphere of Earth, but they were held, they were trapped, they were captured by the Earth's magnetic field. So imagine if Earth's magnetic field was not there, this would have entered and this would have caused a lot of damage to the humans as well as to the life on Earth. And over a period of time, Earth similar to Mars would have been a barren land. Okay. So this is Van Allen radiation belt. This is how it looks like. There are two belts, as I said, outer and inner one. You can see both of them mentioned differently in different colors. Okay, I hope this is understood to you. Now, what is the process of South Atlantic Anomaly? See, this over the last 200 years, we have seen that the magnetic field has lost its strength by almost 9% on an average. And more recently, over the last 50 years, the strength has dropped drastically. That is from 24,000 nanoteslas to 22,000 nanoteslas in the last 50 years. That is from 1970 to 2020. So if you remember the definition from the first slide, where I mentioned that it's a weakening of Earth's geomagnetic field. It's a weakening process, right? Or it's a behavioral change. So that behavioral change is where you can see that the strength of the magnetic field is reducing in a particular point between South America and southwest of Africa. That's a particular region where this anomaly is seen. Okay, there this weakening happens, and that weakening is known as South Atlantic Anomaly. I can show you the image, but just wait for some time, it would come. And this area is actually growing. Now it's not remaining constant, it's actually growing, and it's moving westwards. Westwards is like it's trying to move towards or cover towards Africa and then towards into Indian Ocean and those regions. Okay, and what is the rate of this expansion? It's somewhere around 20 kilometers per year. Now, how does this anomaly happen? Like this magnetic field has lost its strength, right? And it's that there is a weakness in it. That's what South Atlantic Anomaly means. How does this happen? The reason is yet not conclusive. We don't have a very conclusive reason for this. People say different reasons, but all of them, let me tell you, all of them are not conclusive yet. But scientists have got different reasons. I myself have provided 3 reasons from what the scientists have said. One is there could be some changes in the electricity flow that happens in the outer core. See, we talked about Earth's magnetic field, right? So that emanates or originates from the outer core, or the electricity flow that happens in the outer core. So there could be some changes there that could have led to this anomaly. Other thing is like there could be some more complex processes which are involved in this entire Earth's magnetic field generation, which are yet unknown to man. So that could be the reason behind it. So there are many things which are unknown to man, right? This could be an unknown reason. There could be an unknown reason behind it, which we don't know yet. Okay, that could be the reason. And even you should understand that these magnetic poles that we have, that we say like north magnetic pole, south magnetic pole, and all, these magnetic poles get reversed every 250,000 years. Every 250,000 years, this gets reversed. So that could also be a reason for South Atlantic anomaly. That could also be a reason for South Atlantic anomaly. Okay, so moving further, let me just check. I'm so sorry. Hold on a second. Okay, so I'm so sorry for the glitch. Yeah, so this could be reversed every 250,000 years. Maybe that's the reason. We don't know yet. Now, I had in the introduction mentioned about a dent. So, what do you mean by a dent? So, I have shown two plastic balls here, right? One on the right and one on the left. On the right, you don't see a dent. On the left, you see a dent. So, basically, this is the dent. See, don't consider the ball to be Earth. Okay, it's not Earth. It's not Earth. But consider the ball to be the magnetic field covering the Earth. Consider the ball to be the magnetic field covering the Earth. Now, the dent portion that you see is the South Atlantic Anomaly region, which extends from South America to the southwest of Africa. So that's the region. So dent is the place where you see that the normal height of the Van Allen radiation belt, which was starting from 640 kilometers, which used to extend till 58,000 kilometers, right from the surface of the earth, it has dipped down. And it has dipped down to 200 kilometers from the surface of the earth. That dip is the place where the dent has happened. The dip is the place where the dent has happened. To explain that dip, I have taken this particular image. I hope I am clear with my explanation. So the dent is a region where South Atlantic anomaly happens. That is exactly the place where what happens is the inner Van Allen radiation belt, which should have been found at a height of 640 kilometers from the surface of the earth, is now just found at a height of 200 kilometers. Which is actually a cause of concern. So that's the region in the image that you can see marked in white and blue. Yeah, I mean the borders are marked in white. And what is the impact of South Atlantic anomaly? So now you understand that this is an anomaly in the Earth's geomagnetic field. What's the impact of it? See, first of all, this South Atlantic anomaly, it's being said that in future, in the near future or in the coming future, this entire one belt could be split into two. You can see it as a one belt, right? Or a one anomaly region. So it could be split into two smaller holes or smaller circles. That's what they say. If that happens, this kind of change could help us understand pole reversal and other processes which are involved in Earth's core. Basically, it would help us understand the Earth's magnetic field in a better way and also about the Earth's interior. Because, see, people say that in the coming some years there is a possibility of pole reversal happening to the Earth's magnetic field. So that's why they're saying that the South Atlantic anomaly could be split into two separate low points in the coming future, which can help us understand the pole reversal and the processes happening inside the Earth's core. Now, at the surface level, what happens? See, at the surface level, South Atlantic anomaly causes no harm because it's not reaching the surface. It is still at a height of 200 kilometers from the surface of the Earth. So it is not going to cause any alarm for us. It's not going to cause any harm for the humans who are staying on the Earth. But I mean, they're also saying that if the pole shift happens or a pole reversal happens, people won't feel any change. But what I'm trying to tell you, if the dent intensifies, let's say it intensifies even come, it's dipping down till the height of 200 kilometers from the surface of the Earth. If it dips further, and let's say if it reaches the Earth's surface, what would happen then? Then the charged particles which are captured in this belt would reach the humans. And when it reaches the humans, when it interacts with the humans, these solar winds and cosmic rays which carries these harmful, what do you say, charged particles, they can alter the DNA of the humans, of all the entire life on Earth as well. So that can lead to very, very, very serious issues. Other issues that can happen is the satellite and other spacecraft which fly in this region. When I mean the satellites are always orbiting the Earth, right? So when they fly through this region, they can experience technical malfunctions due to its interactions with these charged particles. So the weaker magnetic field in this region can force these particles to penetrate into low Earth orbit satellites. They will penetrate into satellites and probably they can damage the systems on board the satellites as well. So that's the issue here. I'm sorry. There's one more damage that can be caused by this. It can cause damage to the ISS, International Space Station. You understand what is International Space Station? Yeah. So I hope you understand it. If you don't know, just go back and check it because um, that's not the point of contention here. So that's why I'm not gone in detail into that. So International Space Station is a kind of laboratory where astronauts live in space. Okay, pioneered by US and Russia is also there in this. Okay, it's there orbiting the Earth somewhere in the space. Okay, so this can also be damaged. Other things that can be impacted are navigation mapping would be impacted, telecommunications would be impacted because all these devices are on board the satellites, right? And the satellites, when it passes through these regions, if it's affected, then because all these things are all they all rely on the geomagnetic field as well, right? So if anything goes wrong with the geomagnetic field, your computers, mobile phones, and other devices could also face difficulties. So that's very important anomaly. Keep that in mind. It can also harm migrations of migratory birds. There are migratory birds like the flamingos and other migratory birds like the falcons and all, right? And even turtles, which are migratory wherein there are migratory species. All of them depend upon the magnetic field for their migrations to a somewhat little extent. So if there are changes in the magnetic field, their migratory routes can also be, or paths can also be disturbed. Okay, so these are issues that can come due to, that can be impacted due to South Atlantic anomaly. On the right, you can see a graph, and that graph is nothing but the reduction in the weakening of the Earth's magnetic field, or the reduction in the power of the Earth's magnetic field. You understand that the power is measured in Teslas or nanoteslas, right? We had in one of the slides mentioned that it reduced from 24,000 nanoteslas to 22,000 nanoteslas, right? So that's the same graph that you can see here, but the graph extends from 1850 onwards to 2020. Okay, so it has covered almost 170 years, right? 170 years. You can see from around 28,000 nanoteslas, it has now reached 22,000 nanoteslas over the past so many years. That's what I tried to show in this particular graph. What is the way forward? What can you do to counter this particular South Atlantic anomaly? So one thing is that you switch off non-essential components on the satellites when they are passing through the South Atlantic anomaly. As simple as that. So that can reduce the impact. Second thing is you can have multiple set of components, not just one set of components. You can carry two set of components. So if one gets damaged, the other one would still be working and would be fine, and your processing at the ground stations would not be affected. So that's one another method of countering this. One more thing is like one more thing that can be done is International Space Station. See, most of the systems on board the ISS are placed inside it, but there are certain systems which are placed outside ISS as well, outside the ISS. There, what happens is like uh, we need to find out a more potential method or more potential materials which can protect such systems which are fitted on the outside of ISS from these kind of radiations and charged particles. Okay, so these are the three things that can be done. There's one more thing. I mentioned in the beginning that this entire news came a couple of months back, maybe in the month of May or June, right? So this concept is already there in news, right? Since so many years, you can see like this thing it started in the 1850s or maybe even before that. So, but the acceleration had started from 1970 onwards. So that's the time when we started analyzing it. So this was already there in news. But the European Space Agency has a satellite known as Swarm satellites. So that Swarm satellites produced a recent update of it, which said that it's weakening at a faster rate in the month of May or June. So that is when this came back into focus. This came back into the news. It was already in news, but it was somewhat dormant. But now it's back in news. So what am I trying to say is like more information that can be achieved from swarm satellites may help us understand Earth's interior and the South Atlantic Anomaly as a whole. And probably we can get some solutions from there. Okay, so these are the things that we had to understand as part of the concept of South Atlantic Anomaly. I tried to cover it in as much detail as possible, and I have tried to cover every dimension of it, okay, every aspect of it, even providing you with a way forward. So as we plan a mains answer writing paper, I try to cover every aspect of it. So I hope you would have understood the video, understood the concept. If you have understood it, well and good. Do hit the like button, do subscribe to the channel, and do comment as well. Even if you didn't understand anything, please do comment, please do ask questions. We would be there to help you. And in case of any queries regarding the channel, regarding any other things, regarding inquiries, you can call us. You can follow us at the provided information 999-161-181-16183. That there is a Genius Channel mobile app available in the Play Store. You can download it and you can use it for your studies. Website and Telegram channel are also there, which you can follow us, which you can use to follow us. Okay, so do hit the like button, subscribe, and do comment. And also do comment if you have any doubts. Please, we would be there to help you. Thank you, guys. Thanks a lot for joining the session. I hope you really like this session on South Atlantic Anomaly. Thanks a lot.